Okay, so yesterday we kind of reviewed more with factoring and solving equations, which we've kind of done already. But remember that if it's not factorable, we have completing the square and we have the quadratic formula. And I know that many of you hate completing the square, but there are certain times, especially when we're putting it in vertex form, and next semester when we talk about something called conic sections, that we have to be able to complete the square. So I'm going to review that with you. So remember, if you're completing the square, 1, the x squared has to be by itself. And then 2, we're moving this c over, and we're trying to complete that to make it a perfect square. So I said move c to the other side of the equation, divide by a if needed. And so then the next step is you take half of that middle number and you square it. So half of b is b squared, b over 2 squared, and you add that to both sides. So that's the next step. And then the idea is you should be able to factor that into half of that middle number squared. And we'll kind of go through one of those. But then from there, you can solve it. And this really is the proof of where the quadratic formula comes from, just so you know. Because if I kept solving this now, I would have x plus b over 2 squared. And then over here, I would have negative c plus b squared over 4. And then the a is 1 in here, so that's kind of where this is going to be weird. But then you would take the square root of all of that. So you would have x plus b over 2 equals plus or minus the square root of, if I got a common denominator there, that would become 4c plus b squared all over 4. So you can kind of see where that comes from. If I move this over, I would get negative b over 2 plus or minus the square root of b squared minus 4c all over 2. You can see we're just missing the a because a happens to be 1. But just so you know, that's kind of where that comes from, why the quadratic formula works. It's not just a magic formula. But let's do an example here, a couple examples of completing the square, just so I can remind you of it. And then again, you can do the quadratic formula after that if you want. But if the x squared is by itself, then I'm just going to leave a spot and move that negative 3 over. Half of 5 is negative 5 halves. And I'm going to square that to both sides, which is just going to be 25 over 4. So when I factor that, it should always factor into half of that middle number. So half of negative 5 is x minus 5 halves squared. And then over here, you can get a common denominator. That would be 3 over 1. So that would be negative 12 over 4. Plus 25 over 4 would give me 13 over 4. And then I would take the square root of both sides. And I get x minus 5 halves equals plus or minus. The square root of 13 doesn't work out nice, but the square root of 4 is 2. So getting x by itself, I get 5 halves plus or minus the square root of 13 halves, which is fine answer. Or if you want to write it all as one big thing over 2, right? Those are the same thing. It's still 2 answers there. I don't do completing the square that often, but it is something that we do have to do at some point on certain problems. The worst part is when there's a number in front, like on this one. So the first thing I would do on this problem is divide everything by 4. So that would give me 1/4 x in the middle. And I'm going to go ahead and add that 3/4 over to the other side. And then my rule is I have to take half of the middle number. So if I take half of 1/4, that's the same as multiplying by half, would be 1/8 squared. So 1/8 squared, which when I add that to the other side, 1/8 squared is 1/64. And again, if you follow that pattern, every time when you factor, it's always that number before you squared it. So that's x plus 1/8 squared. And over here, gosh, I got to do some math here. 4 times 16 is 64. So I got to do 3 times 16 on the top. So that would be 48 over 64 plus 1 over 64, which works out really nice to give me 49 over 64. So when I take the square root of both sides, I get x plus 1/8 equals plus or minus, and that's a perfect square. So that's 7 over 8. So when I subtract the 1/8 over, be careful, you get two answers here. You get 7/8 minus 1/8, which is 6/8 or 3/4. So that's one answer. Or we get negative 7/8 minus 1/8, which is negative 8 over 8 or negative 1. All right? So completing the square, it's going to pop up here and there. So it's important to look at it, okay? But what for most of us, when we use to solve an equation that's not factorable, is we do the quadratic formula. And again, we derive that from completing the square. And if you just solve that for x with completing the square, you have to know this. Negative b plus or minus the square root of b squared minus 4ac all over 2a. And that's how we can solve things without completing the square. When we talk about the quadratic formula, we always talk about the discriminant. The discriminant, what's under the square root. And you can tell what kind of answers they're going to have just based on what's under that square root. And so if what's under that square root is greater than 0, you're always going to have two real and unequal roots, which means you're going to get two different solutions, two different x-intercepts. If that square root equals 0, then that whole thing is gone, and you're just left with negative b over 2a, which means that you're going to get one solution. If you graph that, it's going to just be the vertex on the x-axis. And then if it's less than 0, then we get no real solutions, no real number answers, and those would be complex numbers when we do those, okay? So just real quick, if we review doing this, one, you can't do the quadratic formula unless it's equal to 0. So if you had a problem like this, it's not equal to 0, it's equal to 3. Step 1 is you have to work that out and get 6x minus 2x squared equals 3. And if it was me, I'm going to add everything over to make that positive. So I'm going to get 2x squared minus 6x plus 3 as my quadratic. And then I'm just going to do the quadratic formula. So that would be negative b plus or minus the square root of b squared, which is 36, minus 4 times 2 times 3, all over 2 times 2. And I cannot stress enough, I say it in Algebra 2, I'm going to say it again. Show me a little bit of work here so that you can get some partial credit. And then I'm just going to type this in my calculator. 36 minus 4 times 2 times 3 is 12. All over 4, and we need to have a kind of a little bit of a talk about simplifying these answers. Remember that you have to break up the square root of 12, so you could break that up as 3 and 4. So that would be the same, right? Square root of 3 and square root of 4 would be the same as 2 square root of 3. And now, since everything's divisible by 2, the square root of 3 is just going to stay there. My best answer here would be 3 plus or minus the square root of 3 all over 2, because I'm just dividing everything by 2. Biggest mistakes that happen with these are simplifying. If I do another one here, this one's already in the right form. Quadratic formula always works. Factoring only works when it's factorable. So that's why some of you already said, why am I not just doing the quadratic formula on this? Especially because you can just use your calculator. So negative b plus or minus the square root of b squared. Notice I always square that so I don't mess up a negative. Times, oh look, I already messed up. That's not right. B squared would be negative 30 squared, which would be 900 minus 4 times 9 times 25 all over 2 times a. Now, if I type that in my calculator, minus 4 times 9 times 25, oh my gosh, I get 0 here. So this is an example that the discriminant is 0. So my answer is just 30 over 18. Or if I simplify that, that would be divided by 2, 15 over 9. And I just get that one answer when I graph that. I think, yeah. This is the last one here, and it says the height above ground in feet of a rocket t seconds after it's launched is given by this equation. When will the rocket be 180 feet above the ground? And so a question like this is the equation that they're giving us. 180 feet is the height that we're going to plug in here. So we get 180 equals negative 16t squared plus 120t. Again, I always like to keep that positive, so I'm going to add that over and say 16t squared minus 120t plus 180 equals 0. And now that's just a quadratic equation to solve to find out the time of when that rocket will be that high. I always hope that this is divisible by 16 to make my number smaller, but if not, I can just do the quadratic formula here. So what I want you to do is set up that quadratic formula, and then in class we'll finish up here to make sure we can kind of think about some applications of quadratic equations.